third part is f of x 4 minus x square, and the interval is -2 to 2. Actually, our given interval or given domain is from -2 to +2. Now we will check the behavior of the given function under this interval, whether the function is increasing or decreasing in between from -2 to +2. For this, we first apply derivative. So f prime of x will become -2x, as derivative of 4 due to the constant function will become 0. So the derivative will become -2x. Now we put f prime of x is equal to 0. So -2x is equal to 0 and x is equal to 0. This is the value where f prime of x, or first derivative, is 0. So we can say our subintervals are -2 to 0 and from 0 to 2. So this one is actually the partition -2 to 2, which is -2 to 0, and then the next one is from 0 to 2. We divided this given interval -2 to 0 into subintervals -2 to +2. For -2 to 0, f prime of x is equal to -2x, which is greater than 0, as -2 to 0 is this one from 0 to -2, which contain all negative values. When we put a negative value to this x, multiplying to -2 will become a positive number or greater than 0. So we can say that -2 to 0, the first derivative of the given function, which is -2x, will return a positive value. Hence we can say f of x in increasing in -2 to 0. Due to the definition of the increasing function, that derivative of the given function is greater than 0, then the function will become increasing in the given domain or given interval. Hence we can say f of x is increasing in interval -2 to 0. Now we check the next subinterval, which is 0 to 2, which is this one. This is the value, or this one is the interval 0 to 2, which contain all the positive values. So for 0 to 2, f prime of x is less than 0, as when we replace this x by all these values from 0 to 2, which are positive numbers, multiplying to -2 will return a negative number or less than 0. Hence we can say f of x is decreasing in interval 0 to 2. So as a whole, in this given interval -2 to 2, we first divided this interval in two subintervals, -2 to 0 and 0 to 2, and then check the behavior. We will find that a function is increasing in interval -2 to 0, and then f of x is decreasing in interval 0 to 2. So almost the same question, f of x, the next part, x square plus 3x plus 2, and the given domain is -4 to 1. First we draw this interval -4 to 1. Let this one is origin 0, 1, and the negative value -4. -4 to 1. This one is our whole interval from -4 to +1. So our given interval is from -4 to +1. Let's start our solution. First apply derivative, then f prime of x, or first derivative will become 2x plus 3. The derivative of x square will become 2x, and derivative of 3x is 3, and derivative of 2 due to the constant function is 0. First we put this first derivative is equal to 0, so that we can get the value where this first derivative will become 0, and we can divide whole interval into some subintervals. So 2x plus 3 is equal to 0, and this will give x is equal to -3 by 2. So this is the value where the first derivative will become 0. -3 by 2 is actually -1.5. So we can mention it out here that this one is minus 1.5. So our whole interval minus 4 to 1 is divided into two subintervals from minus 4 to minus 1.5 and then minus 1.5 to 1. Now we'll check the behavior whether the function is increasing or decreasing in two subintervals. So the subintervals are minus 4 to minus 3 by 2 and the next subinterval is minus 3 by 2 to 1. First we check in interval minus 4 to minus 3 by 2, f prime of x 2x plus 3 is less than 0 in this interval minus 4 to minus 3 by 2. You can check it yourself that when we put the value of x from this value minus 4 to minus 3 by 2, we will get a negative value of this function which is our first derivative, and if first derivative will return a negative value, then f of x is decreasing in the interval minus 4 to minus 3 by 2, and by definition that if first derivative is less than 0, then the given function will become decreasing. And similarly, when we get or when we check the next subinterval minus 3 by 2 to 1, then f prime of x will return a positive value under this interval minus 3 by 2 to 1 or minus 1.5 to 1. So f of x is increasing in interval minus 3 by 2 to 1. So this one is actually the procedure. If we check from all these four parts, that if we want to check the given function is increasing or decreasing in the given domain, then first apply derivative and then put the derivative is equal to 0, so that we can get our stationary point is actually where the function is neither increasing nor decreasing. So this one is the value where function will be neither increasing nor decreasing, and at that stationary point the function will return increasing behavior or decreasing behavior before that stationary point and increasing or decreasing behavior after that stationary point. So this one is the requirement to get our increasing or decreasing function, that we put our first derivative is equal to 0, then get the value or get the stationary point and form the subintervals of the given interval, then check one by one of these subintervals to check whether the first derivative is less than 0 or greater than 0. If the first derivative is less than 0, then the function will be, then the original function, the given function will be decreasing, or if the first derivative will return a positive value, then the given function will become increasing in that particular subinterval.